Yes, okay, so rational, irrational is how we split the numbers. E and pi and funky numbers, root of 2 and root of 7 were in irrational. What's in rational? So what kind of numbers are in the rational number family? 4 is, yes. 1/2, so fractions. Whole numbers, finite numbers. Decimals. Negative, we're missing one key one. Perfect square roots. So like square root of 4, square root of 16. Rational means fractions. Because decimals are fractions. Whole numbers are fractions. Integers are fractions. A rational expression is a polynomial divided by a polynomial. What's a polynomial? Things. Does it have to have 3? Does it have to have 2? More than 1. And what do we call these things? Terms. So it's a group of terms. If it's got 2, we know it's a binomial, trinomial, monomial. So it's really easy. Rational expression would be 4 over x. 4 is a polynomial, x is a polynomial. We might get a little crazy and be like, ooh, negative 3 over x plus 1. So there's a monomial over a binomial. We might be like, ooh, they're ready for x plus 2 over x minus 5. There's a binomial over a binomial. Or we could go like total crazy town and do a trinomial. So x squared plus 5x plus 6 divided by another trinomial, x squared plus 7x plus 12. So what we're going to do today is talk about something called NPVs. The homework tonight is the video on simplifying these. So how do we make this more simple? Then we'll look at multiplying. So this one times this one, for example. Dividing, add them, subtract them, equate them to something, and solve them. That's what the whole unit is about, is take these guys and do a bunch of stuff with them. We're going to talk about these things called NPVs because these are going to come up in every single question. You're going to be so sick of NPVs by the end of this unit. So there's a couple things in math that are really, really, really bad if you do them. A couple things like your paper will explode, your calculator will give you an error, a few things that are really, really bad in math. So we saw in the trig, when you try to inverse cos or sine a number that's bigger than 1, that's when you get that error. Other thing you can't do is you can't divide by 0. And this is people are always like, is something with a 0, but is it when it's on top or when it's on the bottom? So what's 0 divided by 4? Well, what does that mean is take 0 objects and divide them among 4 people. If I have 0 candies and I wanted to give them to 4 of you, how many candies would you each get? 0. I'm so generous. What about the other way around? What if I had 4 candies and I wanted to split them among 0 people?
Impossible.
Why is that impossible?
Because you can't divide like you don't have anything.
I'm still going to have 4 candies in my hand. I can't get rid of them. So even if I give them to no people, what do I do with the 4 candies? So there's a law in math saying we can't divide by 0 because it's impossible. And that's when you divide by 0 in your calc, you get that error. You're going to end up with situations where you're dividing by 0 because these are fractions. The number that makes the denominator equal to 0, the number that makes the denominator equal to 0 is called an NPV, a non-permissible value. And so every time we're dealing with a rational expression, we always have to state the NPVs. We have to start out by saying these are the values for n that are not good. Because when we get down to solving equations, we need to know that, and that'll come up in a bit. So if I look at this 4 divided by x, what can x not be? 0. Because if I put in 0 for that x, I'm going to divide by 0. But what about the second one? 0 is okay for this one, because if I put 0 plus 1 on the bottom, I get plus 1. That's okay. What number is not going to be good here? Why negative 1? Because negative 1 plus 1 equals 0. So we would say the NPVs for the second one is negative 1. What about the third one? What are the NPVs for this one? 5, because if I stick in 5, I get 5 minus 5, which is 0. That's what an NPV is. It's called a non-permissible value, or sometimes it's called a restriction, or sometimes an excluded value. They all mean the exact same thing. Non-permissible value, restriction, excluded value, or any values of the variable that makes the denominator equal to 0. So at the beginning of the unit, they're not going to really be that important, but we're going to practice finding them because they're going to become really important when we're solving. And next unit, we're going to graph these guys, and they're going to become really, really important with the graphing. So through all this unit, we're going to practice finding the NPVs. So every question, when it says add, it'll say, and state the NPVs. Divide, and state the NPVs. Solve, and state the NPVs. So every question will end with, and state the NPVs. Brad, true? State the NPVs. Here's a method how to find an NPV. Equate the denominator to 0. And solve for x. Equate the denominator to 0 and solve for x. So for simpler ones, it's fairly easy. You could tell right away this first one was 0, this was going to be -1, this was going to be 5. What about something like this? Okay, that's what we'll look at in a second. So you can probably look at this and figure out what the bottom is going to be. What's the number that's going to make this 0? Here's y. We take x minus 3 and equate it to 0. And then we want to get that x by itself. So how do we get rid of -3? We add 3. So we say x equals 3. You don't need to show the work if your brain can see it's 3. I'm just going through the math. Sometimes we'll get super funky and put this little slash through the equal sign. What does that mean? Yeah, and typically we'll say NPVs are what x cannot be. So you'll see them stated as this a lot. X cannot be 3. Why can it not be 3? Because if it is 3, we've got 0 on the bottom, and it's going to give us an error. So let's look at ones that are a little bit more complicated. Number 2 is when they're going to give you 2 different variables on the bottom, and you're multiplying them together. So 2 variables, and you're multiplying. What you want to do is just split them up and do it separately. So I'm going to start by equating to 0. So take the whole thing, make it equal to 0. Now, way back when we were solving quadratics, we looked at the rule that when you're multiplying 2 things, and the answer is 0, what do we get to do with them? When you have 2 things you're multiplying and the answer is 0, what do we get to do with the 2 things? They're typically binomials. They're not in this particular one. But what do we do when we have 2 binomials multiplied by each other? We split them up. So I'm just going to split this right between the 2 variables. And I'm going to say x cubed might be 0, or y might be 0. So when you have 2 or more variables and you're multiplying, it just becomes a split and solve. How do I get rid of the cubed? What's the opposite of cubing something? Cube rooting something. And for some reason, when it's 0, it freaks people out and they don't know what to do here. What's the number times a number times a number, same number, that gives you 0 as an answer? 0. It has to have been 0. So we say x cannot be 0 is the first NPV, or the first restriction. What about here? Y cannot be 0. So this one happens to have 2 restrictions. It's got x cannot be 0 and y cannot be 0. Okay, what about when it's a binomial on the bottom? Same first step, equate to 0 and solve. Oh my god, what kind of equation is this? How many ways are there to solve a quadratic?
4.
What are the 4 ways? Told you they'd come back in 2 more units. Here it is. Which method would you like to use? No, I heard factor first, so we're factoring. No, I heard factoring, we're factoring. I heard it first. What do we do after we factor? Split and solve. So for the first binomial, x cannot be. And the second binomial, x cannot be 2. Okay, what do we do here? Same first step. Take the denominator, set it equal to 0. What about the numerator? Why are we always focused on the denominator? Why is he more important? There's something on the top there. He's important too. He can be 0. We don't care what he is. It's just the bottom. So this example is when you've got two variables but you're adding. So this was two variables you were multiplying. This is two variables you were adding. The only thing you can do is what's called solve one with respect to the other. Solve one with respect to the other. It means pick one of the variables and isolate it. You can pick the x, you can pick the y. It's totally up to you. Which one would you like to isolate? Okay, so we want to get this little x here by itself. What do we do with that 10y? This is called solving with respect to the other variable because it means x depends on y. It depends what y is to matter what x is. If y is 2, for example, what can x not be? If y was 2, what could x not be? Negative 4. What if x was 4? Or y, sorry, was 4. What could x not be? What if y was 0? What could x not be? 0. So that's called interdependent variables. Here's what to do when you are multiplying two variables. Here's what you do when you're add or subtracting two variables. Questions so far? There's finding NPVs. What you need to do tonight, and you've got more than enough time to do it now in class, because this is all I have for you today, so you can get it done now, is you're going to snap the QR code. If you forgot the program or you don't have it anymore, it's called iNigma, is the one I use. And so when you open it, the video will pop up. It's 15 minutes, 21 seconds long. This will be the first example. All you need to do is copy down how they did it. When you get to the method box, you're making your own method. So this is not in the video. You're going to pause the video, figure out from here what was step 1, what was step 2, what was step 3. And when we come back together tomorrow, this is the first thing we're going to compare together. What did you have as method? What did you have? Oh, I like your step 1. Oh, I really like your step 4. Okay, let's change it. Let's get a good method. Everyone does not need the same method because everyone's brain is different. So you're pausing, you're figuring out your method. Then you're copying example 2. You're copying example 3 and 4. I've put optional in if you're still like, not getting it. This is optional. This applet is not working this morning, so try it tonight if it's working. I don't know, but it's not working right at this moment. Turning the page, this one is. So you're going to snap this. It's going to ask you to do a couple questions. You need to do 2, at least 2. Show me the work, and then you stop. At the end, I've also put it like, hey, if you're still not getting it, here's some pages in your workbook you can read. So again, optional at the back. That's what you need to have done tomorrow up to this dot right here, the stop button.